Assalamualaikum and good morning. Today we're going to continue with chapter 3a, breakdown in gases, and the topic for today's lecture is Paschen law. Chapter 3a consists of 4 topics. Topic 1, introduction. Topic 2, breakdown mechanisms. Topic 3, Paschen law. Topic 4, breakdown in non-uniform fields and practical consideration. So for this lecture, we are going to look at Topic 3, which is Paschen law. Topic 1 and Topic 2 we have covered previously in class. So make sure you go back and do your own revision, okay, and refer to your lecture notes. Okay, the objective for this lecture is to learn what is Paschen law and describe the related Paschen curve. Paschen law states that breakdown voltage between two parallel plate electrodes in a gas is a function of the product of the gas density ρ and the gap distance between the two electrodes d. And this is given by V equals to some function f, and the function contains this term ρ times d. It has been shown previously that Townsend breakdown criterion in gases is given by gamma times exponent alpha d minus 1 equals to 1, where the coefficients alpha and gamma are functions of E over rho given by alpha over rho equals to F1 E over rho and gamma equals to F2 E over rho. And we also know that E equals to V over D. So if we substitute for E into alpha and gamma, we would have alpha over rho equals to F1 V over D rho, and gamma equals to F2 V over D rho. And if we rewrite equation 4, we will get, okay, so this is equation 4, and we substitute this and this into this one, okay, we will get this equation. And this equation implies that the breakdown voltage Vs varies with the product rho d. We can also write equation 9 as Vs equals to F and D, where Vs is the breakdown voltage, rho pressure, D gap distance, and N is the concentration of the particles. If we plot Vs versus rho D, we will get a curve, and that curve is known as Paschen curve. This is a Paschen curve. On your y-axis, you have your Vs, and on your x-axis, you have your rho D. So we have two regions. So the first region is region rho D less than rho D minimum. Okay, and the other region is rho D greater than rho D minimum. And there is one important point on the curve, which is the Vs minimum. So when Vs minimum, your rho D is also minimum. For values of rho D greater than rho D minimum, okay, so we are talking about this region here, okay. So the electrons crossing the gap between the two electrodes, they make more frequent collisions with the gas molecule than at rho D minimum. And the collisions reduce the electron's energy, and therefore that will make it more difficult for the electrons to ionize a molecule. Because if you remember from our previous lecture, okay, for ionization to occur, the kinetic energy of the electron has to be greater than the ionization potential of the gas molecule. So if an electron has less kinetic energy, so it will be difficult for the electron to ionize a gas molecule. So energy losses from a greater number of collisions require larger voltages for the electrons to accumulate enough energy so that they can ionize many gas molecules required to produce an avalanche. For rho d less than rho d minimum, so now we are talking about this region. Okay, this region. Okay. Okay, the electrons might gain a lot of energy, but they have fewer ionizing collisions. So a greater voltage is required to ensure ionization of enough gas molecule to start an avalanche. Minimum breakdown voltage. In general, Paschen law breakdown voltage can also be written as Vs equals to B rho d divided by ln A rho d divided by ln 1 plus 1 over gamma, where A and B are constant. And the minimum breakdown voltage is given by Vs min equals to 2.718B divided by A times ln 1 plus 1 over gamma. And this value will give the minimum point on the Paschen curve. Okay, as a summary, Paschen law states that the breakdown voltage between two parallel plate electrodes in a gas is a function of rho times d. And a plot of V versus rho d is called as Paschen curve. And the minimum point on Paschen curve represents the minimum voltage required for breakdown in a gas insulator. That's it. Thank you.